Okay, so we're going to do sets. So one of the best ways of me showing about sets is to use the Venn diagrams. So we'll have a look at what they mean, look at some questions. If you work through the book, I'll add the book to the when I send it to you, and I'll send you some assessment questions on Wednesday to do with this. There are some questions I think in the PowerPoint which you have to do as well. So first of all, we have a universal set, which is a set of everything. Then we have if we've got a set A and a set B, then this little like n thing is the intersection. So it's only what is in A and B. It's got to be in both. Okay. This is the union, and it can be in either. So as long as it's in A or B, so this that should be all really. So it can be in either A or B. It doesn't have to be in both. It can just be in one of them. It can be in both, but it can just be in one of them. This A little dash is the complement of A, so it's everything outside A. This line here is a subset. So basically A is within B, so it's not. It could be all of B. It could be one part of B, or it could be any number of different things between all of the values and one of the values. As long as it has one value, then it's a subset. And if you don't have an empty set, it's written like that. So a circle with a line through. So that's the notation. We'll have a look at how that's used. So here I've got a set A and set B. The set A is 4, 7, 9. The set B is 1, 2, 3, 4, and 5. Okay, and so and the set of the universal set is all the numbers 0 to 9. So 0 would go on the outside. 1 is only in set B. 2 is only in set B. 3 is only in set B. 4 is in both. 5 is only in set B. 6 is not in either. 7 is only in A. 8 is not in either. And 9 is in set A. Okay, so the so if I wanted the intersection, so if I wanted A intersection B, that would just be equal to 4. Okay, if I wanted the union A union B, that would be equal to 1, 2, 3, 4, 5, 7, and 9. I'm not going to write that down because it takes me ages to write this. So 1, 2, 3, 4, 5, 7, and 9. If I wanted a complement, the complement of A, that would be everything outside of A, which would be 1, 2, 3, 5, 6, 8, and 0. Okay. If I wanted the union of A complement of A intersection with B, for instance, so that's everything outside A but also in B. So everything outside A are the ones I just said, but it also has to be in B, and so that would just be 1, 2, 3, and 5. Yeah, okay. There is some other notation as well. Sometimes you get N A intersection B. Okay, so if you see a little n in between with the curly brackets, so A intersection B, well, we all know that's only got 4 in it, so n is just the number of members, so that would be 1 because there's only one value. N for set A is 3, n for set B is 5, n for the union of set A and B would be 1, 2, 3, 4, 5, 6, 7. Okay, so here is a question. Have a go at A, B, C, and D. Here's another question. Have a go at doing that. Okay, so this time they're written out rather than written in notation. So this one is notation. that's written out, understanding, do you know what the intersection union is? Okay, having been that we've just done intersection and union, so you can have a look at those if it helps you to understand the diagram better. So have a go at these questions and these questions here. Okay, you should be able to work through any problems. Just WeChat me. Okay, so let's have a look here. Now we've already said that this here is the intersection of not A and B. Okay, this one here is, we've got A involved, and it's the intersection of not C and not B. Okay, because it's in A but it's not in B and C, and so that's where we get those there. The intersection of A and B would be this value, this bit here, but we want not B, and so we want things outside B, things outside C, and in A. Here we want things outside B and in not in A. The union of those would be something in A, anything outside B, anything outside C. And so it would include all of this value here and everything outside B and C. Right, see if you can do that one. This is quite a difficult question, but have a go, see if you can do it. And have a go at that one as well. So there's two to do there. So that this is something that's in A and B, anything that's in A and B, and it's got to be also in not C, sorry, as well. And this one is the intersection of A and B and the intersection of things that aren't in C as well. Okay, let's see if you can do those two questions. Right, so the last thing we're going to do is have a go at a question that you might get asked to do with sets. So normally you set this up by drawing a Venn diagram like here. So we have F is the set of people who play football, H is the set of people who play hockey. So 8 children play football and hockey, so that's the intersection that goes immediately in the middle. 7 children don't play football or hockey, and that goes there. 13 people play hockey, so if 8 play here, then there must be 5 here. 19 children play football. If there's 8 there, then that must be 11. Okay, so that means in total there is 19, 24, 31 students in that class. Okay, so what is the probability the child plays football? The probability is how many in football, which is 19 out of 31. Okay, the child plays hockey but not football, so that is this bit here. That's the intersection of the people who play hockey and the complement of football. So they play hockey but not football. It's only this value here, which is 5 out of 31. Okay, so this is that a child's picked at random. What's the probability? This is the play both, so it's the intersection. So this is 8 out of 31. Okay, a child swims. Okay, well we don't know. Okay, so you wouldn't get asked quite that question. You could say 0 because it's got no information there, but they might swim. All of them might swim in their spare time, and so you would you put not enough information for that. And here, this is the last one, which is conditional probability. This is given that the child plays football, that they also play hockey. So the child is in here. So we know that there's 19 children. Okay, and that also plays hockey. So given that we're picking out of these 19 students, we know that they're one of these 8. What's the probability of them being one of these 8? Okay, and so it's 8 out of 19. So this is the most difficult question because people always still put 31 down, but this is what's called conditional probability. Okay, so that's the end of the PowerPoint. The questions that are due on the PowerPoint for Wednesday, and then I'll give you some more questions on Wednesday. If you do this one here, I'll give you a starter if we know that's 920 because 920 have no defects. Always start with the intersection. So we don't know there. What we need to do is try and find out what x is. Okay, that's 11 minus x because it says A and B have 11. Okay, so 11 minus x is there. Okay, 13 minus x, 10 minus x. Okay, just by using this information here. 31 have A defect, and so we do 31 minus that, minus that, minus that. Okay, which is 11, 10, 21, so it's 10 minus x, minus x, minus minus x, which is obviously just plus x. If I do the same for B and the same for C, and I know all of these add up to 80. Okay, and so if I add them all up, I get x minus x plus x minus x plus x minus x plus x plus all these values, which is 76 plus x. So that's 80. So x is 4. So if x is 4, then I can fill the rest of the data in. But remember, you've got to, like I did here in the previous slide, always start off by trying to find the intersection first. Okay, now that is the end of the slide.